Okay, so for question number 1 here, okay, we have a closed air column. So right away we know that lambda equals 4L, okay, resonating at its fundamental frequency of 225 hertz. The speed of sound in air is 340 meters per second, and we're looking for the length of the tube. All right, so 1 mark for givens here. Okay, if I'm going to find the length of the tube, okay, using this formula, what do I need that I don't have? I don't have lambda. All right, so I'm going to find it using V equals F times lambda. All right, so lambda will equal V over F, 340 divided by 225. All right, so we're getting our wavelength here to be 1.51 meters. Okay, and so give them a mark for that step. Okay, if they have anything like that, okay, that's the mark for that step. Then we're going to find out what L is. Okay, so L will equal lambda over 4 because we're dealing with a closed air column at its fundamental frequency. So that'll be 1.51 divided by 4. They can have a mark for that step as their third mark. Okay, so our final answer here to 3 significant figures is 0.378 meters for the length of the tube. Okay, fourth and final mark there. Questions on that one? Well, yes, absolutely. If they have 3.78 times 10 to the minus 1, yeah, that's fine. All right. Number 2, we have a 25 centimeter open air column. If you don't convert that to meters, this won't come out right. Okay, that's one of the few dirty tricks I can play on you with these. Okay, it's resonating and it's open, so we've got lambda equals 2L, and it's resonating at its fundamental frequency, F1. Okay, we don't know what it is, but it's resonating at its fundamental frequency. The temperature of the air is 25 degrees Celsius. What's the frequency of the waves? All right, so if I find temperature, I can find what? Or sorry, if I have temperature, I can find what? I can find the speed. All right, so give them a mark for their givens here. Okay, their next step is to calculate the speed of the waves. 332 plus 0.6 times 25 degrees Celsius. All right, so we got 347 meters per second as our speed of sound. Okay, give them a mark for that step. The other thing I need, if I'm going to calculate the frequency, is I need the wavelength. Can I get that with the length of the tube? Okay, that's our next step. Okay, we have to use lambda equals 2L. Okay, so that'll be 2 times 0.25, which means the length of the wavelength of these waves is 0.5 meters. Okay, you give them a mark for that step as well. Okay, now we're going to use V equals F times lambda to find F. So F will equal V divided by lambda, okay, which will be 347 divided by 0.5, fourth mark there. No, that's just a method mark. All right, so our frequency is 694 hertz. Sorry, 2 significant figures. 6.9 times 10 to the 2 hertz. The whole quiz is out of 9, yes. All right, so mark out of 9, let them see it. Put it right here.